In this video, we'll talk about percentiles. Percentiles are position measures used in educational and health-related fields to indicate the position of an individual in a group. Percentiles divide the data into 100 equal groups. Percentiles are symbolized by P1, P2, P3, and so on up to P99, and divide the distribution into 100 groups. So we have here the smallest data value, and then values for P1, P2, P3, and so forth up to P99, and then we'll have the largest data value. In many situations, graphs and tables showing percentiles for measures such as test scores, heights, and weights have already been created from previous data. Percentiles are also used to compare individual scores with the national norm. Tests such as the National Educational Development Test are taken by students, and individual scores are compared with others locally and nationally using percentile ranks. Percentiles are not the same as percentages. If a student gets 72 answers out of 100, she obtains a percentage score of 72. This gives no indication of her position with respect to the rest of her class. If a raw score of 72 corresponds to the 64th percentile, she did better than 64% of the students in her class. The percentile formula corresponding to a given value x is computed using the following formula. Percentile is equal to the number of values below x plus 0.5 divided by the total number of values times 100. Here is an example about traffic violations. The number of traffic violations recorded by a police department for a 10-day period is shown. Find the percentile rank of 16, and the values were given are 22, 19, 25, 24, 18, 15, 9, 12, 16, and 20. The solution is to arrange the data from lowest to highest. 9, 12, 15, 16, 18, 19, 20, 22, 24, 25. Then we substitute into the percentile formula. The number of ranges below x, which in this case is 16, plus 0.5 divided by the total number of values times 100. So that's 3 plus 0.5 over 10 times 100 equals 3.5 over 10 plus 100 times 100, which is 35. The value of 16 is higher than 35% of the data values. To construct a percentile table and graph from raw data, first create a table with data displayed like this. Column A has class boundaries, B has the frequency, C has the cumulative frequency, and D has the cumulative percentage. We fill in the class boundary and frequency data in the table. Then find cumulative frequencies and place them in column C. Find the cumulative percentages, and using the formula cumulative percent equals cumulative frequency divided by n times 100. Then graph the data using class boundaries for the x-axis and cumulative percentages for the y-axis. Here's an example using systolic blood pressure. The frequency distribution for systolic blood pressure readings in millimeters of mercury of 200 randomly selected college students is shown here. Construct a percentile graph. So here is the information we already have for our table, where we've got the class boundaries, the frequency, and we know the total number is 200. So steps 1 and 2 are already completed. We next fill in the cumulative frequencies, 24, 86, 184, 196, and 200. We now calculate cumulative percents for the first class. For the first class, the cumulative percentage is 24 over 200 times 100 is 12%, and we plug these into the table, and I have the table here. The completed table looks like this. So we'll see that our cumulative percentages are 12, 43, 79, 92, 98, and 100. And because I didn't want to do it on paper and make it look terrible, so make sure this is on the right screen, yes, our our graph looks like this. Here it is. It starts at 0 for 89.5, goes up to 12 at 104.5. At 119.5, it's at 43, and 79 for 134.5. 149.5 is at 92, 98 for 164.5, and 100 at 179.5. To find a data value corresponding to a given percentile, first, arrange the data in order. Then substitute into the formula C equals n times p over 100, where n is the total number of values and p is the percentile. 3a, if C is not a whole number, round up to the nearest whole number. Starting at the lowest value, count up to the number that corresponds to the rounded up value. If C is a whole number, the value halfway between the cth and C plus first values when counting up from the lowest value are the percentile, or are the, I'm miswriting something there, but I believe it's supposed to say that is the percentile. I'm going to double check. I apologize for this. Use the value halfway between the cth and C plus first values when counting up from the lowest value to find the data value that corresponds to that percentile. So here we've got one more example. Again, we're using the traffic violations data. So first we arrange the data, and we're looking for the value corresponding to the 65th percentile. We arrange the data, and then we calculate C, which is equal to n times p over 100, which is 10 times 65 over 100, which is 6.5. So we're going to round that up to 7. And then starting at the lowest value, we count up to the 7th value, which is 20. 1, 2, 3, 4, 5, 6, 7 gives us 20. The value of 20 corresponds to the 65th percentile.